Hi everybody, this video is about piecewise functions. Some of this stuff I'm going to go through kind of quickly because you spent a lot of time on it in Math 3. So once we start doing more examples together, it should come back to you pretty easily. So when you have an equation, the first thing that you should look at before you decide how you're going to plug the number in is you have to take a look at the inequalities. So it helps to put the inequalities into words. So I know this inequality means the numbers less than or equal to -3. This means numbers in between -3 and 2. And I'm also paying attention to the fact that these are both less than signs, which means they would go with an open circle. So if I was trying to plug in exactly -3 or exactly 2, I would not use this piece because those are open symbols. All right, the next one, pretty obvious. I'm only going to use that piece if it actually equals 2. And this is for numbers greater than 2. All right, so the first number that I'm trying to plug in is 3. 3 is greater than 2. So this is where you actually plug the numbers in. So 3 squared plus 1 would give me 10. So because 3 is greater than 2, I used that piece. The second one, I'm trying to plug in exactly 2. So that's this middle, that's this piece. This piece is only for when x is equal to 2. So 2 plus 6 is 8. All right, -5. -5 is less than -3. So I'll use this piece. And that's going to give me 13. And then 1 is in between -3 and 2. So whenever you have a piece that is constant, it's not going to change. So that is the output. All right, something that you maybe did not spend as much time on in Math 3 is determining if your function is continuous at a certain point. So that's primarily what we're going to focus on in precalc. We're also going to need that concept a little bit later in the unit when we talk about a limit. So first of all, I want you to notice that the parts that I boxed off, the first one is linear. The second one is just a straight line. Linear, quadratic. If you can remember domain and range from, well, mostly just domain, honestly, is all we care about is domain for this. But linear, quadratic, exponential, all polynomial functions, they all have a domain of -infinity to +infinity, right? They don't have any weird things happening on the graph. The only functions that we have to be careful of are square root functions, because we cannot take the square root of negative numbers, and rational functions, because we cannot divide by 0. So these are all continuous by themselves. To figure out if as a whole graph they are continuous, I have to look at where the first piece stops and the other piece starts. So almost all of these questions are gonna be asking you to find if it's continuous at one of the numbers that you see in the inequality symbol. If this wasn't a number in the inequality symbol and it was just a number like that went straight up with one of these pieces, you just have to look at what kind of an equation it is. Most of the time, it's going to be something that already has all our numbers as the domain. So this is a little bit tricky when we're trying to decide if it's continuous at a breaking point, because I kind of need to know what the graph looks like. If the graph is continuous, then I should be able to trace the whole thing without lifting up my pencil. If it's not continuous, there will be a gap. So when x is -3, I basically need to figure out, does the left piece match the right piece? So the left-hand side of this graph are the x's that are less than or equal to -3. The right-hand side of the graph are the x's that are greater than -3. So basically, I need to check and see if I plug -3 into both of these pieces, am I going to get the same answer? So the first piece from the left, if I plug in -3, that's going to give me 11. This piece included -3, so that would be a closed circle. So my graph is obviously not going to be very much to scale. And if you remember, like y equals mx plus b, this would be a line that had a negative slope. So I'm just going to kind of draw what I know that piece looks like. But the important part is that when I plugged in -3, I got 11. So that's where this piece stopped. Now I need to look at the next piece where -3 is the smaller side and see what we get. So that one is obviously just 7. And that would have an open circle. And honestly, that would be a straight line all the way until x was equal to 2. But I don't really care about the rest of it right now. I only care about what's happening at exactly -3. So because I did not get the same answer, this is no. It is not continuous because I did not get the same answer when I plugged a -3 into the first piece and when I plug -3 into the next piece. All right, so let's do another example just like that. So here I only have 2 pieces. This is for numbers less than -3, greater than or equal to -3. But I want to know, is the graph going to be continuous? So I need to check both pieces. This is the piece that's coming in from the left, where the x's are smaller than -3. And this is the piece that's coming in from the right, where the x's are greater than -3. So I need to plug it into both of those numbers and see what I get. So when I plug it into the left side, I get 9. And that would have an open circle. Well, pretend I drew this a little bit better. Pretend that's at -3. And again, I can tell that that's linear, so I know that's what the other piece is going to look like. All right, coming in from the other side, -3 squared is also 9. And then that would be quadratic. So because I got 9 for both of them, the answer to this is yes. All right, so basically that's all you have to do. You just have to plug the number into the 2 pieces that are the cutoff. So again, like if I asked you, is this function continuous, let's say at f of 5? Let's just pretend I wanted to know, is this function continuous at f of 5? Well, 5 is not a cutoff point. 5 is greater than -3. And this is quadratic. Every single quadratic is continuous. There's nothing weird about quadratics. There's no asymptotes or holes. So this one would automatically be yes. I wouldn't even have to plug anything in. All right, briefly going over how to evaluate piecewise functions from a graph. Remember that that's the x part of the ordered pair. Your job is to find the y part of the ordered pair. So negative 3, it looks like it goes right through 0. This would be the point negative 3, 0, so this answer is just 0. F of negative 2 has an open circle and a closed circle. Open circles have no value, so we only use the closed circle. So that would be the point negative 2, 1, so that answer is just 1. F of 1, again, open circles have no value, so this would be the point 1, 2. And F of 3, looks like there's a point 3, negative 1, so that's just negative 1.